So this video is going to explain the infographic behind me that shows the learning pipeline. It's a model for educators to help understand the process that goes on from the capture of sensory information in the first instance through attention into working memory, then into long-term memory. So I'm up here at the sensory input side, and this is where the input of sensory information lands in the brain from each of our five senses. In an educational context, it's likely to be vision and hearing. And vision in the brain is the strongest sense that we have. It overrides lots of other things. So it has primal position in the brain in terms of input, although other sensory input systems can take over temporary control, if you like the sound of a loud noise that's unexplained. So what happens then broadly as an overview is that sensory information is captured by attention, and this attention then passes that sensory input into working memory, where it combines that sensory input with anything that's being held in temporary memory, this working memory. And it's a little bit like the juggler at the top of this little mini graphic here, that when we're being asked to hold lots of information at once and then do some cognitive work on that, this will then play into that whole concept of cognitive load. If working memory and its cognitive load is optimized, then what will happen is that information will be encoded into long-term memory, and the majority of this will likely happen during sleep or periods of non-sleep deep relaxation, which I would imagine most students don't engage in. As we build concept maps and schemas, then at some point, prior held information in long-term memory will be passed back to working memory for more manipulation and integration with novel concepts. So really, the interaction between working memory and long-term memory is a two-way street, with passing of information back for encoding into long-term memory, and then the retrieval process occurring back into working memory for manipulation or recall. The more often that this happens, the more it's like the flexing of a muscle, and the repetition of that flexing builds the strength of that muscle. So I'll look at the risks involved in each of these stages, and at the sensory input stage, the risk is likely to be around a physiological or biological deficit in one of these sensory inputs. You can imagine the situation for people who have issues with sight, with hearing, and other biomechanical processes that are going in the brain that impinge on the sensory collection of information for attentional input. From the perspective of attention, it's likely to be a management issue more than anything that will be impinging on the ability for attention to be the conduit from sensory input through to working memory. As mentioned before, ADHD and ADD are poorly named. It's not that there's necessarily an attention deficit, but more about the way that attention is actually managed by the attentional centers in the brain. Other risks include lack of sleep, lack of hydration, lack of nutrition, and lack of exercise, lack of mindfulness. These all play into the way that we can optimize the brain, particularly in the way that attention is managed or self-regulated. At the working memory level, cognitive load is the biggest risk, and there's a separate video on cognitive load. And here we need to optimize the cognitive load to reduce or remove extraneous cognitive load, the distractions, the things that don't help, to match and optimize the intrinsic load, the load of understanding and making sense of the task at hand. And then we want to maximize the germane load, the load that's all about connecting the dots and making meaning. At the end of the long-term memory piece, there's quite clearly a brain health issue that's playing into this. But at the process level, it's much more about not making use of the forgetting curve and interleaving, for example, as two strategies that help the brain encode these memories more permanently over time. If we don't return and revise a subject after a set amount of time, the brain begins to prune some of these long-term memories, use it or lose it. So that's one aspect of long-term memory that's a risk that's involved here. And finally, a comment here about the umbrella As a teacher, as a leader of learning and an influencer in the classroom, my belief is that you have strongest impact over the attentional management in the classroom, the attentional culture, and the way that children and students can manipulate and self-direct, self-manage their working memory for the best output possible. So these come down to learning design, delivery design, attentional engagement and management processes, and various aspects of scaffolding and support that don't turn you into a GPS for the students, but supply a series of resources and mechanisms that allow students to be self-regulating and to take ownership over their learning. So what stands out for you in this pipeline? Where do you see you need to grow your own skill development more? What things do you think I might have missed, or what questions are being raised? I'd love to know more.